Alright, this is Ayush Kumar Gaur and I hereby present my idea on ICP Hackathon. So, we know that VPNs today are fundamentally flawed. They are built on centralized servers, operated by a company we are supposed to trust with our most private data, but we don't really know what happens behind the scenes. Tor was a step forward. It's open and decentralized, but let's face it, it's painfully slow and unusable for anything beyond light browsing. On the other hand, commercial VPNs like Nord, Surfshark, Express, they might promise privacy, but they are just glorified internet service providers. You are routing all the traffic through a server you rent. The problem is simple. Current VPNs ask you to trust infrastructure you don't control, and you can see how problematic it is at the first place. And they don't scale with the decentralized web. Alright, coming to the next slide, here is my solution to the problem. Ninja VPN, a Web3 based decentralized VPN network. Ninja VPN is built on the internet computer and powered by smart canisters, tiny programs that run on the chain. Instead of routing your data through one path, we split the page into multiple 2 MB chunks, and each chunks travel through its own private 3-node encrypted chain. It's like having n parallel Tor tunnels, all moving at once, each independently encrypted and all programmable. This isn't just faster, it's smarter. Each chunk stream can be verified, paid by cycles, logged on chain and scaled on demand. No need for volunteer, no need for centralized servers. Just pure composable privacy as code. Want to add region filters, rate limits, on-chain authorization? Just update the protocol logic. It's yours to control. This scales in a way Tor never could. Where Tor bottlenecks at volunteer nodes, Ninja VPN spawns new chains with traffic. More usage just mean more nodes. This is what a Web3 VPN should be. Fast, verifiable, modular, and most importantly decentralized by design. I have built a miniature prototype to prove this work. But this is just a beginning. Ninja VPN is the future of programmable privacy on chain, and we are just getting started. Now, I want to walk you through what I have built so far, a working miniature prototype of Ninja VPN. Because I was allotted a limited number of cycles on the internet computer, I could only build a single end-to-end encrypted chain for this demo. But even this is enough to prove the core idea. Here's how it is structured. Node 1 acts as entry point. It accepts a base64 encoded URL. This simulates user traffic entering the network. That input is passed to node 2, which acts as a forwarder, simulating the middle relay in our chain. Finally, the node 3 makes the actual outbound HTTP request using ICE cycles. This node simulates the exit proxy, the one that contacts the internet and returns data. Now, here's the catch. Internet computer has strict limits on outbound requests related to IP4 bounded sites. So, to pass that, I integrated a fly.io based proxy that lets node 3 call a backend running off chain, which then completes the real HTTP request. The entire system is stateless, spawnable, and every interaction is logged and visible. Each node could run independently or as a part of a swarm, making this setup perfect for decentralization and scaling. So while this is just a single chain for now, it lays the groundwork for a much more powerful architecture. Alright, now I will display a live demo of this VPN project I have created. So my miniature project is largely a backend project. However, I have created this dashboard like structure front end, as you can see. And once you come here, you will see something like a URL bar, and the moment you click the browse button, it will basically the fetch content from this website, ipinfo.io/json. So what is it? This is actually a website that basically tells you your IP address and your current location. So I have specially chosen this website to be like a default value in this input, so that you can check um if this VPN is working or not. So as you can see, this site has given like a JSON response to us that basically tells us that we are currently in Mumbai city and this is our IP address. However, when I run this on my own computer without using the VPN, I get something like this kind of response, which is correct. So this clearly indicates that my VPN, or let's say the miniature version of that, is working properly, and that's it.